Hi, this is David Caputo, product manager for Cribl Search, and I'm going to be showing you today how to build a simple anomaly detection analytic using search operators. Okay, so this is what the analytic looks like. I'll zoom in on it just so you can take a look at it if you want to copy and paste that. And here is a paste bin if you want to grab that URL so you don't have to retype the search. Okay, so what this search analytic is showing us, the TLDR, is that we have black bars, which are showing us the CPU meter for this particular host, and yellow bars where that CPU meter is above the threshold, represented by a 10-minute average, which is in the grayish blue in the background. So we're going to show you how to build this analytic from scratch. So if we go over here and look at our edge nodes, we'll see that we have one particular edge node, and we have the CPU of that particular edge node that we can take a look at here. And we can maybe extend this out to a 12-hour view and sort of take a look at what that looks like in edge. And you'll see that there's a flurry of activity today, or in the past hour or so, and then many hours ago earlier. So if we take a look at how to build that exact same view in search, we can go over here and start from Cribl Edge Metrics. We'll click on that, and it will automatically connect to my edge and pull results back in. Now we know that we want to look at our default fleet, so we can click there. It automatically adds to the search. We can click host, and this is the one host that I have in my fleet, so I'll do that. And we also know we're interested in CPU metrics, so I'll click there. Now let's rerun this search and see what we get. Now we're going to have a little bit of a different set of fields. Notice that we do have that one host that we expected. We have in the metric source of CPU. There's a bunch of different types of CPU meters, but the one we're going to use is this node CPU percentage active all. So what we can do now is then add another clause to our search, which is going to be, we can get rid of this limit, and that's going to be a time stats. Notice we have type ahead, so we can go to time stats, hit tab, and then we're going to want something like an average. So let's say we're going to take average of that node, and notice again, it auto-populates with the type ahead. So I'm going to hit tab to complete, close parentheses, and that's it. I'm going to hit enter to re-execute the search. And now we'll see that now we have what looks like 1 minute summaries of averages of that metric. Notice that it does auto scale to the highest metric there, but we can go over here and change the y-axis if we want. Since we know that the maximum is 100 on the CPU scale, we can do that. So that's simple, and we can also change the color of this bar to black, because we're going to try to be consistent about that. Now, we know we want to also have multiple series, averages, and standard deviations. So we're going to give this a name so we can take advantage of our implicit naming here. So we're going to call this CPU average equals like that. We're also going to do a bucketization. So we're going to ask it to do span equals 10 minutes. So we can look at 10-minute averages. Now, if we're doing a 1 hour time window with 10-minute averages, we're going to expect to see 6 results. So we do. We actually have 6 results there. Now, so we can extend this once we have the data that we want. We can extend the time window, but we know we also want averages and standard deviations. And since we're averaging out the results, one way to get the largest result in that time period, of course, is use the maximum operator. So we're going to use the maximum. We'll have the average, and then we'll use the standard deviation. And again, that auto-populates there. Okay, so now we should re-execute it, and we should have 3 data series over the 1 hour block that we're looking, which is 3, which should give us the 3 different data series: CPU max, CPU average, and CPU standard deviation. Okay, re-executing that search, and we'll see that we get 3 different data series. And again, each one of them give us 6 points because we've specified 10-minute bucketization on a 1 hour average. Let's change again. Let's change those colors again. So we'll keep the maximum to be so this nice black color, and then we'll go for like a bluish color for the 2 different series here. We'll also maybe make these, well, let's just leave it like that for now. So as a reminder that the black series is the one that we're going to be caring about. If you want to, you can also make the average an area chart to show you that that's sort of averaged over time. Now what we want to do is add a z-score component to that. So we're going to use the extend command, and we'll call it z underscore score, z underscore score, and let's say 4. So 4 standard deviations above the mean. And then we'll add a second command here, a second parameter, and we're going to say, we're going to call it delta equals the CPU standard deviation, STD, to do times the z-score. And that's going to give us basically a new set of fields, which will, our new data series, which is we'll be able to add to the existing average to give us that new envelope that we're going to look above and below. So if we take a look at what we have now, we should now have a new field called delta, which is going to show us how much we're going to add or subtract from the mean to create our envelope. So we'll create another series. We'll use extend again. We could have used the same line, but just to make it more readable, we're going to make a new line. So we'll say extend, and we'll call it env for envelope high equals CPU average plus delta. So that's going to give us a high average. We could also add, and the example as a low average where you're doing CPU minus delta. But for the ease of what we're doing here, let's just stick with that. So now we should be able to show an envelope here where we're visualizing the mean plus the standard deviation. And that is the env high series. So to make it easier to see, let's remove some of these from the plot. So we're going to go remove, we don't need to see the z-score here, remove. We don't need to see the standard deviation at the same time. So we can hit remove, and we don't even need to see the average. Plot remove. So now we just have the CPU and the envelope. So that's starting to look like kind of what we want to do. So let's maybe extend this to 12 hours, not 121 hours, to 12 hours, and re-execute the search and see if we can see a little bit more to it than that. Okay, re-executing it brings these back on. So let's just remove these. So we'll remove the delta, we'll remove the z-score. And there's actually an easier way to do that rather than doing it one at a time. And I'll show you that in a moment. But so again, what we really want is the CPU and the high end of the envelope. So we can use another function called project, and we'll say we want just CPU max and env high, and that's just going to give you the two fields that we were interested in, CPU max and env high. So that's sort of the basis for what we're trying to accomplish. Oh, that was interesting. Let's re-execute that. That's what happens when you start messing with the search in the middle of it. There we go. Whoops, I realized what I did. I projected away the time field in time stats. So that's probably not terribly useful. So we're going to use the project away command. And in other words, I got rid of time when I'm trying to plot by time. So I'm going to tell it to get rid of explicitly which fields we want to get rid of. So we're going to get rid of CPU average. We're going to get rid of delta, get rid of z-score, and CPU STD, the standard deviation. So that should just leave us with the max and the high envelope. So again, project away is the opposite of project. Rather than specifying what you'd like to keep, you specify what you'd like to get rid of. So here now we have two data series with the maximum and the high envelope. And again, I can click that, select that back to an area chart. Now you can see, so now we have the CPUs, and then we have the maximum, the CPU envelope in the background, and then the maximums popping out here. Now, what we don't have is right now we don't have them highlighted. So let's see if we can create that highlight as something that stands out visually. So what we're going to do is use another field here, or another function, another extend function, and we're going to basically test to see if the CPU is higher than the envelope. Then we're going to create this field called with 1, and if it's lower, otherwise we're going to create a field called 0, and we're going to call that that field anomaly flag. So that's just going to be basically a yes or no field showing us all the times when the maximum value of the CPU is higher than the 4 standard deviations beyond the mean. So we can see that there are places where it is and places where it's not. In fact, if we wanted to highlight there, we could go to highlighting and we could change it to a specific heat map so we could see that there are places where it is in fact higher. So now what we'll do is we'll add yet another extend command, and we're going to create a new data series called anomaly chart. And we're basically going to take advantage of a little computational trick, and we're going to create a second series that is basically exactly the same as the CPU max series, except it only exists when the anomaly flag is 1. And then we'll take the original CPU max series and then make it 0 where the anomaly flag is in fact 1. So we will basically create an invert data series that we can then change the color on. So we're going to call that anomaly chart. And so if we take that anomaly chart and change its color to sort of a bright green color, we can see that there are some locations where we could see that bright green color. So let's go back and change the envelope to an area envelope again. And now we're actually starting to see what we'd like to see. We can take that anomaly flag and get it off the plot here. And in fact, we can add it to our project away clause here, which we will add to the end of the analytic now over here, and we'll add anomaly flag to that. So we're getting very close to the final version of the analytic. So let's just re-execute it and see if it is where we like it to be. I notice these results are coming back in very, very quickly. We are executing directly on the edge node, and you'll see, so you see the CPU meter, that H top jump up every time that we do run the execution. I do notice, however, that's for some of these low values, it is showing up as an anomaly just because it is so low. So what I'm going to do is actually add a little bit of a fudge factor for the specific limit right up here. And we're going to put that fudge factor in just to set the limits of the high envelope to be 95 to 5. So they're basically pushing up. So nothing below 5 will trigger it, and everything above 95 will trigger it, just as a way to kind of keep the overall envelope in making mathematical sense in the context of a percentage field. So that's sort of a little, if you feel uncomfortable with that, I can understand. But that's kind of a way to make the mathematical analytic make a little bit more practical sense in this context. So here now you see we're back to the basically only the things that are popping up above the envelope showing as yellow. Notice, by the way, we do see some yellows in here, which is interesting because we plot 0 values as 1 pixel high bucket. So if you want to get rid of those, you can change your min to 1, and that will make the 0 values go away. Okay, so that's pretty much what the final analytic is supposed to look like. Now you can see here that we're showing you load over time. And we're showing you yellow bars in the places where it is in fact bigger than the envelope. And if we wanted to test this, I could go down here and just run a little load generator, which you see will pin the CPU to 100%. Now, obviously, since this is just a T2 micro, it doesn't have it only has 1 core, and it doesn't take a lot to make it pretty busy. But next time now, if we execute this search, it will take just a smidge longer because now it's obviously that host is busy doing things, but you can see immediately that we get that 100% anomaly jumping right out. And so the idea is that this is the kind of analytic that it's designed to draw attention to itself when something unusual is happening. Now, clearly on a normal machine that has many cores, you won't have this background noise of the actually executing the search causing it to be anomalous. But Anytime you do execute the search, or anytime that you do have a load, you should see this anomaly pop up above the mean. And certainly any of these numbers can be tweaked. You can use different standard deviations. You can use different timescales. But this is the basic idea of how to use search and the functions that are built into search to generate things like anomaly detection. And that's it. And again, thank you so much. I appreciate your listening. If you have any questions, feel free to reach out to me on Slack or any of the other websites we have in corporation. Thanks so much. Take care.